the Next Gen AI with Sai YouTube channel. Today we are going to continue the second part of our video, that is real time. Those who are watching first time, I would recommend please watch the first part of this video so that you will understand what we are trying to achieve. But just to kickstart this, let me revise what we have done in our first part. So if you see this, in first part we discuss what we are trying to achieve. We have built the code, okay, and in current part we also continue the same thing. So we are trying to build this real-time app, which is a kind, you can say, a support app. It's a kind of a bot where user is asking a questions to our app, and we are building those app using Streamlit. This Streamlit app connect to our backend API. So for that we are going to use the FastAPI, and it connect to our agents, and those agents are built using Langgraph. So this is what something we are trying to achieve, and currently we are in the process. So I'm not going in depth, but this is what something we are doing. For the in-depth understanding, watch the first part of this video. Now let me take it to the VS Code. As we are going in reverse, so when I say reverse, so first we are building the agents, then we are going to build the API on top of these agents, so that whenever the front end asks any questions, it will hit the API, and API trigger the specific agents, and then last we are going to build the Streamlit app. So let me talk about the what code we have done for the agent building till now. As we know that the Langgraph is a kind of an enhanced version of LangChain, where we are building the agents in the form of nodes. Those nodes are communicating with each other through edges. Now we are in the process of building a node, and then we will see how these nodes can be connected to each other. So what node we have built till now? We built some node which is the intent classifications. So intent classification node will understand what is the intent of the question that user has asked. Second node is a retrieval rack. So second node, based on the intent, once the intent is classification is done, the retrieval node help us to retrieve the relevant documents from the knowledge base that we have built upon. And then third, we have that is called as the third node, that is something we are saying response generation. Now I have the node one done the intent. Second, I have retrieved the data. Now based on the intent and based on the data that I have retrieved, okay, I want my LLM to respond on that. Okay, so let's start coding about the response generation. Now for the response generation, again we are going to write, let's give the name of response generation as a response node. So as it's a async, we are doing this asynchronization, so I have to write the async method before the def. The response node, we want context, and those contexts we are storing in the class called as chat state. So as I explained earlier, this chat state help those contexts to be shared across all the node, response in the dictionary of string. Then first we are saying that from the class state I want to retrieve the message, okay, which is in the my context. So let me retrieve the message first. Then I'm going to retrieve the intent, which is in the state class state, okay, which is intent. If it is there is no intent, then I will consider as a general. And third is the context, okay, which is in the form of context. Okay, if I try to retrieve the context, if there is no context, I will say this as a empty. Okay, now I'm saying if there is no message, then there is a, I will suggest, I will give the response, sorry, I didn't receive any message. Now the third is the prompt. So what prompt I am saying that you are helpful precise assistant for SaaS product support system. based on the user intent retrieve, provide the concise relevant response. This is the user intent, this is a retrieve context, okay, and this is a user message, correct. And now here I have the support response. So I would just add one more line here, okay, so that, or maybe probably I'll do one thing, I'll just restructure this message so that restructure this prompt so that it is aligned with the what we are trying to achieve. Okay, so this is what prompt, which is same as what is earlier that our copilot has been given in an automated way, but this is the refine as per our business product. Okay, similarly when you are writing the prompt for your business, you have to refine those prompts. Just don't believe, or just don't rely on the prompt that given by the copilot. Now whatever response, whatever prompt I'm giving, I need to pass this prompt to my LLM invoke step method. So this is a private method we have already built. Okay, if you have missed this, so please go and watch the part 1 where I have explained how our LLM invoke method works. So basically in short, let me just so this is LLM AI invoke step method. So basically what this method is trying to do, based on the LLM call, it will send those prompt and invoke the specific method of LLM. This is the inbuilt method given by a line chain, and it will try to send those response to that specific method and extract the result. And how these results as going to be extract, that also we have written some functionality. So please go and watch that. Watch the first part. Now once we receive the response, then we are at the logger, the generated response. So we just want one logger information so that all the information we can see in the log as well. Now this response is a raw response, it is not correct. I mean this is not the refined version of output. So we just need to say response. So whatever response we will see, we just need to stream it. Okay, and then we are saying raw.stream. So this way we have defined our node 3. Let's try to see the node 4. In the node 4, we are trying to add, that is the safety layer. Okay, so safety layer, for example, there are few words that we want that our bot should not provide a response. You can say it will act as a guardrails. So we are not using any library. I mean, we are not using any third-party tools for the guardrail, but generally this kind of the guardrails is already provided by the cloud provider. Okay, or if you want some output our LLM should not respond, so you can also write such a uh, custom node for this. So let me say safety node, right? I want now in the chat set we also storing the response. So from there we wanted to get the response and then strip it. If no response, then we say I couldn't generate. Then here we wanted to add the keywords. Okay, which keywords we wanted to restrict it. Okay, so let me add those line here. Okay, so we are saying that if keyword lower for keyword in restricted keywords. Okay, so what are those restricted keywords? Let me mention those restricted keywords here. Okay, so any restricted keywords related to the diagnosis, prescribe, legal advice, medical advice or anything related to lawyer, okay, then we have to provide the response that I am unable to provide medical or rigor, please consult the qualified professional. So this is what response we're trying to give it, correct? Now once this done, now we have defined all our nodes. Now it is time to compile this node in a graphical format. So the last stage of this, let's say build a Langgraph workflow. Okay, so to initiate the Langgraph, this is the first line where we are initialize the state graph, and here we have to pass the class or the context that we are sharing across the load. So chat state is a class we have defined. Then now we have to add each node, right? So our first node is the intent node. So intent is the intent node, and we are giving name to that intent node is a intent as a short form. Second node we have that is retrieve. So we are saying that add node, the name of the function is retrieve and the retrieve node. Now let's not add any dependency as such. Let's just first define the retrieve node. The next we have something called as the response node, that is a third node that we have defined, and the fourth node that we have created, that is the safety node. So we are adding all these nodes to all my graph. Okay. Now once I have added all the node, now it is part. Okay. So let me just okay, let me complete the code and then we will again switch to the whiteboard. So to explain the summarized version of this, just to get the intuition. Now I have added all the node. Now I have to put which is my entry node. Okay, so for this I say graph dot set entry node is the um, entry point is method of why it is graph entry point. So I say my entry point of this graph is a intent, right? Then I once my entry point is done, then I have to add the edges. So I say my edge is between from my intent to retrieve. After the retrieve, my edge is between retrieve to response, and after response I want safety node has to be triggered, so response to safety, right? And then I have to mention which one is my the last node, right? So I have to mention the set finish node, finish point. Okay, so finish point is safety, right? So safety is my last node, and then I have to compile this. So when I say compile, so what will happen? Langgraph create this version, compile version in the OS. So whenever we start, it will do this way. So graph dot compile. Okay, so graph dot compile is the method through which you can compile all this. So I hope now you understood. Let me just go and do the whiteboarding first, so that just to give the pictorial presentation what we have did. Okay, fine. So what we have done in the line graph. So these are the node we have added. So first node is the intent node. So please remember the start is the entry point where actually graph line graph start working. After the start we have intent node where we have written all the logic how my intent agent or you can say node has to work. So it will try to understand, classify the questions of user, okay, based on the defined keyword. Then after intent we are saying my second node will be the retrieve. So basically whatever the classification we have done or whatever the, so here is the, here will be the user, right? User will ask some question, right? Based on the question it will do the intent classification, then retrieve classification. So retrieve, we have here vector database through which it will retrieve some information, and then it will go to the third node, that is something called as the response. Okay, so it will try to get response from the which LLM. Okay, so we are sending all this information to LLM along with the user prompt. Now, once response is done, then we are saying that whatever responses we are receiving, we have to check whether it is response related to the business, or maybe the response that we do not want user should get. So there are few keywords we wanted to restrict our LLM should not respond. So you can say this is a kind of a mini guardrails, right? Or you can say customized guardrails, where we are restricting few words, and in our application we are restricting something is related to medical or something is related to the legal. My LLM should not provide the, or my bot or my application should not generate the response. And then we are saying this is the end. So this is what the pictorial representation, right? So one thing please remember, these square boxes, these square boxes, these square boxes, right? These all are called node, right? And how this node to coordinate with each other, okay? How to coordinate with each other? For that, we have joined them to edges, okay? And we also mentioning that there are few things that node has to aware, or has to be, you know, uh, the informations. For that we are writing, we have wrote the state, and this state is nothing but the chat state. This you can give any name, but what this state, the state is nothing but the information or context, right? So in our case, what is our context? Our context is, one is the intent, second is the context, third is the response, okay, and fourth is the user input, that is we have seen message. We want these all information, right? These all information, my all load, my all load must be aware, must be aware. So we have storing all this information in the state. So this is called as the, this is how my Langgraph look like. I hope now our agentic code is pretty clear to you. Okay, after watching first video and now start of this thread. Now let's, as you understood, let's switch to the next part, next component, and the next component is the building this fast API. Now let's see how we can build this fast API. Now let's start the backend, for which we require app.py file. Let me add file app.py, or we can also write, let me write the answer as the main entry. Sometimes people prefer app, but me prefer main.py file. In that main.py file, we are going to write our PI code, the fast code. As usual, we need to require few package. So as we are running a synchronization, asynchronous way. So let me import the async package, then import logging, then import OS, uh, then OS, then import UUID, okay, for to have the unique identifier, okay, UUID, Then I require few class from FastAPI. Import the FastAPI. Then HTTP exceptions and request. Then for the structure output, we are using Pydantic. So from Pydantic, we are import base model, also the base settings, and from FastAPI dot middleware, I need to import the course middleware. I'll talk in a minute what exactly is this. Okay. Then, as we have initialized graph, um, uh, so in the uh, in the Langgraph, so we need to import from graph import app graph. Okay, this is something that we require. We can also can make sure that we can have the init.py file. So at the time of initialization, these packets get also we can add the .py. Here we can copy this from main.py app dot sorry from graph import app graph. Okay. So as we have written under this in init underscore init underscore dot py, so we declare that this work as a package. So when we are importing any method or any variable in other py file, make sure that you import it here. However, after Python 3.3, this is not mandatory, but still it's a good practice, good habit to mention to mention this thing in the init.py, because when you start the Python code, whatever you writing here, it initialize first. Okay, now Python consider this as a package and it is easy to run. It will not throw any error. Great. Now we have done this. Here we also wrote to be added in py, so there will be a two. Now let's do first logging setup. Same thing we have done earlier in our graph code. So I said logging dot basic config. Okay, level is the info, as I already explained in my part 1 how this level works. So anything above info consider will consider in the logging. So let me say now format. Okay, and now what kind of format I want time, then I want level name. Okay, name, level, and the message. Okay, you can add or you can put anything. So for this is the this is also fine. Then we have complete the bracket, still getting this error. Okay, over to the form. Now logging info is done. Okay, logger equal to logging dot get logger. Okay, add name to get logger as delta I backend. Fine. So I added name to my logger. Now we need to do few settings. Okay, so let me say class settings. Okay, and I will import the class base settings. Okay, base setting is my parent class, this is my child class. Now let me say allowed origins. So in allowed origin, I'm going type of this allowed origin, I'll pick it as a list of string. I'm allowing my origin as a http. So I allow my this front end to be run. Okay, localhost 8501. Okay, 8501. Fine. Allowed origin is a something that where we are saying to our fast API backend that what URL we are allowing to the fast to the backend, right? So for example, localhost 8501, let's say this is my front-end server where my Streamlit app is running. So I'm only allowing this front-end URL to my backend. Apart from that, I'm not allowing any request from any other URL. So for this, we are setting allowed origin. Then we have timeout seconds. So basically, this is a timeout for any API to be executed. If any API request going more than 20, so here consider 20 as a seconds, then we will deny that request. Maximum input length we are specifying to 2000. So any input length more than 2000 we are not considering that request. And after that, declaring the class config and specifying the environment file path. So we are setting up all our environment into .env, and then we initializing this class settings to object. So we creating the object of class settings through this so that we can use it later. Now the next step is to app initialization. So we require a fast API uh, library. So we are saying that app is equal to fast API class, mentioning the title and the version. Okay, so if your app is getting updated, you can update this version and keep the your previous version if you wanted to go back. So currently you are saying that 1.0.0 is my version of this current fast API backend. Now the one of the most important part called as a CORS middleware, that is cross origin resource. So cross origin resource is what exactly a gateway to our API. So it's a, you can say it's a gate through which any request comes in. So if you can see here, I'm mentioning what origin I'm allowing, what credential settings I'm doing, what methods I'm saying, and what errors I'm allowing. So let's go back to the WordPad and whiteboard, sorry, and let's see what is this course. So as you can see, the course is basically the cross origin resource sharing. So here we are specifying the what is the rule. If you want to access my fast API backend, what should you follow? So if you can look at this, let me use the highlighter. So this is where I'm saying this is sorry. so, so if you can see, so this is a cross origin resource sharing. Let's say this is my backend, right? This is my backend, right? Where my fast API is running. So whatever request comes here, I'm mentioning my course. Okay, so what this course contains, it contains what origin means, what URL or what services can enter. So where we are mentioning the URL, then what will my header contain. So if you can look at the code, we mentioned start. So all type of header like token, authorization, whatever contains in header we are allowing, but in production we can limit that as well as per the policy. And then the next is the method. So we are mentioning which method is allowed in my fast API. So in our code we are only allowing the post and the optional. Okay, this method we are only allowing in our fast API. So this is very much important and it's required in production setups as well. Now let's check those settings. So if you can see, we are mentioning the allowed origin, that what URL it contain, credentials too. So it will allow all kind of cookies, tokens, then allow method post on option. So option is sent by the browser. This is not just that is something that your application, Streamlit application is sending. It's generating by the browser to check whether you have connectivity with your backend or not. Okay, so this is option sent by the browser, and we are allowing all the headers. After that we have class. Now once we have done these settings, now we require some model. So how we want our API backend to receive the request and how it should provide the output. For that we are creating our uh, customized class, say query, which is inherited from the base model, and saying the message. So all fast API, we are saying that all our API accepting the request through this class. And similarly I can also design how my API should respond the output. For that I'm creating the customized data structure through class, that is chat response inherited from res model, and I'm saying that response is equal, which is in the string format, and the request ID in the string format. So whenever any output my model, my API is sharing, this is the response type of chat response, which has this two you can say a kind of variable response and the request. So each response has these two fields. Now, before starting any API, customized API, it's recommended to always write the health API. So basically what checks whenever your Streamlit app trying to connect to your app fast API, that is your API server, we always hit the health API. So it gives whether your API server is up and running, whether your Streamlit app is able to connect to your API or not, API server or not. For that, it is recommended always write in this format. So that as you remember, we are saying app.getHealth. So specifically we are checking the health of our API server. Okay, this is a standardized format. If it is, if once your app able to restore a fast API and if it returns okay, means your API backend is API server is good. Now then we have chat endpoint. So we are saying the post. So we are only specifying the post request, okay, which is accessible through chat, and our response model is a chat response. So whatever API hit to the chat API, whatever request hit to the chat API, it always responds in this format. Before any message coming to this chat API, we accept the request. We require these two fields. One is the query, another is the request. So we will talk about query is nothing but the message that we receive from the user. Then we are generating the unique request ID, that is unique identifier, that from which user we are getting this, because we are treating that each request is contains the which each request has a unique identifier, so that it is we are able to differentiate between the those messages. So we are generating those unique ID through UUID, and then we are adding that information in the log. Then if there is any blank message before and after the message, we are just stripping that and storing into the text. And if there is a no text, or if the text length is greater than the max input length, we are raising the HTTP exception with the specific code. Now the point is that now let's invoke the graph, right? Now the point we reach, how we can access the graph, right? So if your app graph has the input, has the attribute AI invoke, okay, then we are going in the asynchronization method. We are waiting for that to the earlier process has to be happen, and then we are storing the output into the result. If app graph has doesn't have any attribute of AI invoke, then we are going into the loop, I mean the step-by-step executions, because we need to check whether our graph supports asynchronization or not. If it supports asynchronization, then our code follow this block. If it doesn't support asynchronization, then we are going into the loop, and we will wait till that one by one follow. So this is the, you can say, a legacy method. I mean this is a, this block of code support, this support invoke is a sync and run in a thread in a run in a thread pool, and this is basically async. Invoke is a async. So what is difference between this and this? I hope the things are getting clear. But generally we always prefer async, because async it's a fast, pretty specifically fast in nature than sync. If there is any error, then we are raising the then we are raising HTTPS exception with some, maybe there is a timeout exception, or maybe a request got failed internally, right? Maybe there is an internal server error. Now we reach to the point that is we wanted to extract the response. So how we can extract the response? So for that we have to write some code, right? So let's write the extract response code. So here we are setting up the response text is equal to optional. Okay, so we are not saying any specific. So we are setting the response text is the list of string message, which is none. It is not always we require a response, but sometime maybe, right? So we are saying if is in his instance If your result is a dictionary type, then we are saying response text is equal to result dot get response, right? If it is a dictionary format, then we are extracting the response from the result keyword. Or or if your result, maybe let me write in a another way, just follow our old method. Else, okay, else response text is equal to response text is equal to get attribute result comma response none. Okay, so we are just trying to get the, it is just trying to get the result from this response. Okay, if it is no, then it will return the none output. Fine. So this way we are trying to capture the result. Okay, one note, if you guys are not following with me, please follow, please do the coding with me, so that you will understand each and everything. If you require any more explanation about any line, please let me know in the comment section. I will reply on to that chat with proper response. And if you like it, please give thumbs up. Now we have got the response, right? Now the next step is, if we did not receive any response text, what we should do, right? Then if not response text, then we have to add the logger. Okay, logger dot error. So logger has a error methodology where we are saying request return empty response. Okay, and which response is returned, for that we are going to mention the request id. So for this specific request we are not getting in a response, and we will raise the http exception. Okay, we are going to raise the http exception, which has the uh, which has the status code 500, and it is failed to generate this one. Please try again. Are we missing indentation? Yes. Fine, great. Now this part is clear. Great. And if we are able to get the response, right? If we are getting response and this is not coming, then we have to add the info message. Logger.info request is processed successfully. And then finally we have to return the chat response. Second, let me see, are we not correct? So we have to listen chat response. So in my chat response, I am saying my chat response contain the response, which is a response dot text. Maybe if you can add strip, that is also fine, and which return the request ID is equal to request ID. So this way my backend code is, sorry, not backend code, my fast API code is completed. So till now guys, what we have completed, let me summarize the things in a brief. So let me close this, let me close this. Okay, come again here. Okay, so in first part, if you haven't seen that, please go and watch it, that's totally fine. So in the graph.py we created our nodes. Okay, we created our agents in which we specify what LLM we are going to run. So we have initialized with the model initialization. In the second part we created vector store, where we are storing or creating the vectors of all our data. Then created the state definition, which is one of the core part of the Langgraph. Then we wrote the method for how we are returning, extract the text from result. Then we are handling a method for LLM AI invoke shape. So whenever we are getting any LLM response, okay, according to the LLM method, whether it's a AI invoke or synchronous, asynchronous, we are dealing with those response. Then here we have created the different node. The first node is the intent classification, where we wanted to understand what is the intent of the user. Second node to retrieval rags. So based on the user input, we are retrieving the what text, that what information that I need to fetch from my vector database. Then the third node is a response generation. So based on the data we fetch from our vector database, based on the user message, we are wanted to response, right? So the response node, and then last is the safety. It act as a guardrail. So we do not want our LLM to provide any hallucinated results, not hallucinated, or maybe to be specific, which is unrelated, okay, irrelevant response. Okay, we want our bot to be response on only specific subject. So we have on again specify the node, and then at the end we specify how my graph will look like. So we add all the node we have created, and then we connected all these node. So our graph will start from the intent, then it is connected to the drive, then it is connected to response, and then at the end it connected to the safety, and then at the end it will provide the output. Okay, we specify what will be my entry point and what will be my finish point. So this is a very general and the standard, I can say, standalone flow. Okay, means it will execute one by one by one. Great. Now as we have done here, then in the second part, I mean in today's video, in second part of this real-time app things, we have created the API. So we have, let me just go to the dashboard so that someone watching first time, they can understand pretty well. Great. So in our first part of the video, so in our first part of the video, we have created the graph, or you can say our agent. Now I want this agent to be communicated to my front end via back API. Okay. So in today's video, we wrote the API. Okay, API to connect to my agent. So in second part, we have completed this fast API. Okay, what part we have completed? Just let's revise. Okay, so in the main.py, I have imported all the required library which require to build my API. I imported my app graph. Okay, and then I added some logger. I created do some kind of settings which is require my API server to adhere. Okay, and then I wrote the model how my input to be accepted by API and how API should provide the response, and then I wrote the API which is the main API of our application, that is chat API, and to respond those chat API what are all other edge cases I need to handle. Okay, so as we are restricting how my test to look like, how my output should go, for that we also deal with the whether it's a synchronous or asynchronous. Accordingly I have wrote the code here, and then if not, then there is a exception cases, right? And then the last part of this API, how my response should go out, right? So if there is no response, it is giving the error. If the response in the form of dictionary, then I will get it from those dictionary. If it is attribute, if the result is a response attribute, then I will send it as it is, and then I then return my response in this format. So great, my API is also ready. I hope you understood. No, then please throw in a comment section. Put your comment, put your query in a comment section, and if you like it, please share with your friends so they can also learn from this. Now in our next video, we will learn our front end and try to execute this whole code. If any error come, we will solve it together. Okay, thank you so much. Keep watching.